Here we go. Are we ready? Welcome back from spring break. It's time to keep it going. We're still talking about dirt, and we're going to talk about a lot of it. Or maybe more specifically, what happens when a lot of it decides to move. So we're talking about mass movements, sometimes called mass wasting, but mass movement is the way it's presented. So this is when you transfer rock and soil down slope due to gravity. Sometimes slow, sometimes fast. So what you would often see is a rock slide, a landslide, an avalanche. Those are different specific things, and we need to be careful with. Sometimes we use the common name, but the technical name means something slightly different. And so they're not all landslides. They're not all rock slides. So we're going to get into that today. This is after the earthquake in near Fukushima in Japan. This is a landslide that occurred. There is a lot of movement down the slope, crosses roads. This is, we don't think of dirt, but the amount of material coming down a slope like that with so much speed, it's very deadly, very dangerous. And there are a lot of issues with this. Often this is a part of the earthquake, what an earthquake causes, that's the most lethal. People don't, there's not, earthquake shakes and there's not that many people fall down and get hurt. This can often cause a lot of damage. Okay, we're going to look at some of the triggers. So what causes this? Okay, triggers for the mass movement. First of all, the saturation. Yeah, saturation of the soil and material, the oversteeping of the slope, removal of vegetation, and earthquakes. So what do we got? Water. That's first. Water. Whether it's rain or rapid snowmelt, when you oversaturate the dirt, the particles in the dirt slide past each other differently than they did when they were dry. They move downhill freely. Or if it's rain, as the rain itself is flowing, it can pick up particles of loose dirt and roll them down if there's a significant amount of rain. Oversteeping slopes, just there's a certain angle that stuff wants to lay at, and it's called the angle of repose. And when you cut a road into the base of a mountain, when a stream cuts along the bottom of a bank, or when waves crash along the bottom of a cliff, when you get the bottom of those eroded away, the slope now changes angle and the bottom's lost out and things can fall. So the oversteeping of slopes is removal of vegetation. That's bad. Whether it's a forest fire, whether it's human activity, whether it's just killing weeds, roots hold all this together. From April of 1952, there's a horrible, deadly tragedy in France where there was a huge earth landslide where they had removed a whole bunch of olive trees, which have nice deep roots, and planted a whole bunch of carnations, which have real shallow roots, and it led to, then after days of rain, the landslide. Could the trees have prevented it entirely? Maybe, maybe not. Did it help that they were gone? Absolutely no. So big, deep-rooted plants, or even grasses. Grasses will hold the top layer well. So removal of vegetation can trigger this. Earthquake can trigger this, as you see on the screen, and it can be quite dramatic. Okay. Now, we talked about angle of repose. Real quick, we're going to look at, there it is. If you've ever tried to build a sandcastle, the angle of repose, if you just pile more stuff on there, it's going to keep sliding down. And if you can make the cone gets bigger, but at the cone, the sides always stay about the same steepness. In fact, that's important in industry too, because this, depending on what material you're going to pile, whether it's grain or rock or whatever you're mining out of the quarry, the angle of the sides of that cone are different depending on the material. All right, here's a couple more different methods for making this. And so this here, they just lift the can straight up and off, and this stuff falls down the slide. But the angle of repose is from flat on the bench up to this straight line out on the side. I think we've got another one right there. It shows you, here's some examples. And if the soil is dry or wet, makes a big difference in the angle. So there are some sample angles for various substances, various soils. All right, real quick, we're going to try this. We're going to see if this works. I've got like 30 seconds here. You can see.
Now, the part I find interesting, I like to call this stick and slide. Sand clumps together because of friction until it becomes too steep, and then it will slide towards the bottom.
See how that angle right there, there's a change, that angle versus that angle, and it falls, and it's all back to the original angle. That's what he's wanting to show, is that when that bottom starts to slide away, it's leaving material, and then the top is steeper, the bulk here will slide down. All right. So, mass wasting, often called mass movement. All right, we're going to look at rockfalls, slides, slumps, flows, and creeps. We're going to look at those 5 things. But depending on who you're asked, they're categorized really different. There's overlap. There's all sorts of things. So this is a National Park Service. Mass wasting here is an example of a slump. All right. Slump has a nice crescent at the top, and we're going to talk about what a slump is. So first of all, what makes these categories? The kind of material that has moved, how it moved, and how fast it moved. Those determine what it was. So there are falls, specifically rock falls, okay, where we've cut something out. Maybe this is an ocean cliff. Think of a cliffside near the ocean. The waves crash in, and underneath they erode that, and then you've got all of a sudden you've got something that's vertical rock here with that's not doesn't have any support. That can break off and fall. So a rock fall or freely falling rock fragments, they freely falling through the air, they break off and drop almost vertical. It can be common on steep slopes, very high mountains. They can trigger other mass movements. So you can have soil falls. This one is undercut by a river, but the whole chunk of soil, if you start eroding the bottom, will fall. But the fall is almost straight up and down because it's a true fall. We're not talking about slides. All right, topples. Topples are when things fall over. We're not going to worry so much about topples. Slides, okay. You can have rotational and you can have translational. Translational is moving forward. Rotational is spinning. A bicycle wheel does both. It rotates and it translates. So translate is the going forward part. Rotating is the spinning part. And when you put it on the ground, as long as it's not slipping, it does both. Okay? So a slide is a block of material, right, that moves suddenly. So suddenly is important. Suddenly along a flat inclined surface. So in other words, this back here is straight. There's a straight line behind this, and when a piece breaks off. The rotational ones are curved in the backside, and we're going to call that something different. We're going to call that a slump. Okay? So if it has a curve that it breaks off along instead of a straight line, the curved slumps are going to leave more crescents in the back. Their downward movement along a curved surface, they are not as fast. So a slide is moderate, and a slump is slow, maybe up to moderate. So slumps are slower, slides are smoother. Okay, they're straight. Um, Leaves a crescent. Sometimes these are because the slump is because it's over steeped and there's some clay going on. We'll see some different pictures. Debris slide. I'm not super worried about that. Now, flows. All right, flows. Lots of water, and they move as a fluid. In fact, it's almost like just torrents of water coming down the hill that happen to have mud in it, as opposed to rocks are falling down with some water around it. The whole flow moves as a liquid. Okay? So, this is saying you can have sand or silt, you can have an earth flow here. Okay? Earth flows, um, here's a slow earth flow. This is what they can last years. They're very slow, methodical. Mud flows, not very fast, but it's like wet concrete. Think wet concrete coming down the side. As an earth flow is even slower. A mud flow would be a little faster. Wet concrete rolling down the hill. And this has some example speeds over here we've got going on. All right, let's look here. So the rotational landslide, that's a slump. The translational landslide, that's a slide. Now these both say landslide. Well, it could be, depending on what this is, it could be a rock slide or it could be a landslide. It could be a block slide. Rock fall is more up and down. Topples we're not super worried about, right? Mud flow and a creep. We haven't talked about creep yet. Creep is the slowest. Centimeters or even less per year. Just slowly moving. Usually due to a freeze-thaw cycle. You don't see the creep, you see the effects. So let's look at some of these other images for the effects of creep. Here we go. All right. So we're going to talk about, this is outside of Fargo, North Dakota State University. All right. So this is a creep. That fence post used to be vertical, but over years and years and years, the land has moved and it's tipped over. Here, the creep is stressing and cracking the asphalt. Here, the creep is separating the fence posts and pulling them out. This one is one I've seen a lot around here, and I used to wrongly attribute it to something else. I would think that, well, the water eroded the bank, and so this is a tree on the edge of a bank. And then without that, the bank starts to fall, which means the tree tips and curves up because the tree's going to grow up. So when you see that curve in a tree, well, I've got better examples of that. This one isn't just the tree on the side of a slope. There's no creek at the bottom here. Just part of that slope is creeping down. That's due to a creep, all right, because of the freeze-thaw cycle. The other one would be oversteeping, right? As you erode underneath the bank, the top of the bank starts to fall, and then the tree roots kind of hold it together. So it's kind of in between a creep and an oversteeping. The oversteeping is what causes the slide. Nothing slid. Nothing went fast. So it probably really would still be categorized as a creep. But these pictures, the next couple pictures, I'm going to show you, finish this page. This is an earth flow. This is slow. It could last years. It's going to move, maybe an inch a day, maybe a yard a day. But it's going to move very, very small amounts per day. And it can just go and go and go depending on how long the slope is. There's another flow. You can see earth flow down there moving along. All right. Soil creep. That used to grow straight up and down. But as the soil moves down the hill, it rolls, which means now it's tilted sideways. And so now the tree goes straight up, especially when you see several there that have curved. That's an example of creep. There's an example of creep. As the soil slides down over the years, the tree is going to grow vertical. All right. Um, Last thing, there's 50 pages here. We're not going to look through 50 pages, okay? But there's a landslide. That is a straight slope. It's not curved like a slump. It's dirt, so it's not a rock slide. It's a landslide. Very dangerous things, okay? Uh, Loss of life, property damage, the whole thing. Gravity's dragging it, angle of repose, all of that. We've already talked about that. You got that. Oversteeping. So there are different effects of it. Shows how oversteeping. Um, Angle of repose. There, different materials stack at different angles. If those rocks were smaller, some of them would slide. If they were rounded, they would slide differently. Fires increase susceptibility. You know all that. We've talked about all that. All right. Here we go. Rock fall. Rock falls are almost vertical, right? That's what we were talking about. And then the talus is the pile at the bottom. All right. Rock fall. All right. This is the slump. There's a good example of a hillside that has a slump that's coming out of it. All right. And you can see that it doesn't all happen necessarily at once. It can break off into chunks. Oceans cut away here, and you get the top falls down. That's because it's oversteepened. Same thing. You can have a creek or a river do the same thing, and you can have all these other events. You can cut a road in there, and that oversteepens the slope. So we're not going to go through all of this. Debris, debris, debris. I'm not worried about the debris ones. Earth flow, mud flow, creep. All right. So get rid of that. All right. We're wrapping up. We're going to finish up with soil and tests, and you guys have a great day.